Good morning, students. So we are discussing straight lines, and now in this class we are going to find out the foot of perpendicular from a point to a line. So look there. For suppose if I have a point like this, see not like, if I have a line of the equation ax plus by plus c is equals to 0, and if I have a point some p, you may say it as x1 comma y1, right? So I have a point and a line. See, perpendicular from the point to the line is nothing but, if you draw a perpendicular from point to the line, this is called as the perpendicular from the point P to the line here. And now here our discussion is to find the foot of perpendicular. See, what is the foot of perpendicular? This is perpendicular and its foot, in the sense it's this point is known as the foot of perpendicular from the point to the line. See, we have a formula to find this distance, right? Distance from P x1 y1 to the line ax plus by plus c is equals to 0. We can find it using modulus of ax1 plus by1 plus c divided by root of a square plus b square, right? So we have a formula to find this distance, okay? But to find this particular point, to find this foot of this perpendicular, foot in the sense usually what? Just like our foot, right? So this is the perpendicular and it is its foot, and we need to find the coordinates of this particular point. For suppose if you say the coordinates of that particular point has h comma k, okay? Initially I don't know the coordinates of that point, you just let it as h comma k, right? See, this x1 y1 is the given point, line is also given. Just look at the statement, foot of perpendicular from the point to a line. This point is given, line is given, and these two are that, and we are going to find this h comma k. And you just take this foot of perpendicular point, name it as some q, and its coordinates are h comma k. We need to find h and k in terms of this x1 y1 as well as the coefficients abc has to be involved. And now if you look at the diagram, and for sure this pq line is perpendicular to the total line, okay? This pq is perpendicular to the line, yeah. And since this pq is perpendicular to the line, what we need to say? Since they are perpendicular, product of their slopes is minus 1. See, PQ is a line segment, or you may say it as line. This AX plus BY plus C is equals to 0 is a line. And since these two lines are perpendicular, product of their slopes is minus 1. So, its slope is given by K minus Y1 divided by H minus X1 is the slope of this perpendicular, into slope of this line is given by minus A by B, right? Slope of this perpendicular into slope of this line is equals to minus 1. Very clear this is. See, our idea is to find h comma k in terms of x1, y1 as well as in terms of a, b, c, right? And now here if you say this minus and minus get cancelled, then I will rearrange it and I will write it like this. Just look there. See, k minus y1 by h minus x1 into minus a by b is equals to minus 1. So, see, send this h minus x1 that side, a also that side. Just look there. I have this at the end. A times k minus y1 is equals to b times h minus x1. Is it right? See, send these to that side and that product here by cancelling that minus sign. And now in the next step, you send a this side and b this side. It becomes like this. H minus x1 divided by a is equals to k minus y1 by b. Yeah, now look there. See, I have a relation h minus x1 by a is equals to k minus y1 by b, but I don't know whether these two are equals to any other number. See, these two are equal to some other number usually, and since we don't know that number, since these two are equal, that is equals to some t, you just say it like that. Once again let's look there. Here, since this PQ is perpendicular to the line, slope of this PQ into slope of this line is minus 1. Slope of this PQ is this k minus y1 by h minus x1. Slope of this line is minus a by b, and this product is minus 1. So on simplification you have that a into k minus y1 is equals to b into h minus x1. And if you rearrange, you will get that h minus x1 by a is equals to k minus y1 by b. These two are equal and equals to say some t, right? And now you just make h as subject from there and k as subject from there. In the next step we have that, see, h is equals to, send this a and x1 that side, h is equals to at plus x1 and k is equals to bt plus y1. Is there anything wrong? Nothing wrong actually, right? Just look there. Since h minus x1 by a and k minus y1 by b is equals to t, then you are going to make h and k as the subject. So h is equals to at plus x1 and k is equals to bt plus y1. Yeah, our intention is to find h comma k, right? And now we don't know this t. Then if you find t, then there ends our task. To find t, look there here, h comma k is a point on this line, is it right? Since h comma k is a point on this line, for sure this h comma k satisfies this equation. So since ah plus bk plus c is equals to 0, because h comma k is a point on this line, so h comma k will satisfy this line. So replace that x and y with h comma k. We have that ah plus bk plus c is equals to 0. And now h is at plus x1, k is bt plus y1. Replace here, okay? In this ah plus bk plus c, if you replace, a times of at plus x1 plus b times of bt plus y1 plus c is equals to 0. You just make that t as subject now. Just look there, for the space constant directly I will write. See, a into x1, b into y1 plus c. Send these three terms that side. And here you have a square t and b square t. So you just take t out and then make t as subject. From there you will get that t is equals to minus ax1 plus by1 plus c divided by a square plus b square. There is the task. Just look there. See, foot of perpendicular from a point to a line. See how we found it. See, to find that foot of perpendicular from a point to a line, first of all, initially you let that point as h comma k, and by taking that point as h comma k, slope of this PQ into slope of this line is minus a by b. So from there you have a relation between these two and take it as t, and then make h comma k as subject in terms of t. And now if it is enough to find t. So to find that, use the relation, use the thing that way. Since h comma k is on the line, ah plus bk plus c is equals to 0. Replace h with at plus x1, k with bt plus y1. At the end t is equals to minus of ax1 plus by1 plus c by a square plus b square. Just have a look at this. At the end I have t, and now you just replace this t here. So at the end you have a relation, and that relation is enough to find that h comma k. See, since I have no space there, I will write here. So therefore what I have in my hands, h minus x1 divided by a is equals to k minus y1 divided by b is equals to minus of ax1 plus by1 plus c divided by a square plus b square. See, we use this, okay, to find that h comma k. Once have a look at this, finding the foot of perpendicular from a point to a line. Just we derived a formula here and then we move further. So we derived the relation to find the foot of perpendicular from a point to the line. If the given point is x1 y1 and the given line is ax plus by plus c is equals to 0, and the foot of perpendicular what we are going to find, if you say it as h comma k, then the relation is this: h minus x1 by a is equals to k minus y1 by b is equals to minus of ax1 plus by1 plus c by a square plus b square. Now I have a simple problem here. We are going to find the foot of perpendicular from the point minus 2 comma 3 to the line x plus y minus 4 is equals to 0. See how to find this. Yeah, you just let that foot of perpendicular as h comma k. So if you think about the diagram, actually to solve the problem this diagram is not mandatory, but to analyze this, if this point is minus 2 comma 3 and if this line is x plus y minus 4 is equals to 0, from this point we can draw a perpendicular, and now our intention is to find this foot of perpendicular. And to find that foot of perpendicular, since we don't know that, you just let it as h comma k. Then by taking it as h comma k, to find that h comma k, we have to use this particular relation. Yeah, h minus x1 is what? Minus 2 divided by a. A is the coefficient of x and this is 1 is equals to k minus y1 is 3 again by 1 is equals to minus of ax1 plus by1 plus c. See, ax1 plus by1 plus c is nothing but substituting this point in the line. So substitute this point in the line, minus 2 plus 3 minus 4 divided by a square plus b square. Coefficient of x is 1, it's a square, plus again it's a square. So we need to simplify. So h plus 4 is equals to k minus 3 is equals to, in the numerator, minus 2 minus 4 is minus 6, 3 minus 6 is minus 3, already minus sign is there, so 3 minus 2 is the thing. And now h plus 4 and k minus 3 is equals to 3 minus 2, then what you say about h? H is equals to 3 by 2 minus 4 and k is equals to 3 by 2 plus 3. So from there we can find that h comma k. So if you simplify, you will get that h is equals to 2 4 is 8, 3 minus 8 is minus 5 by 2, and there 2 3 is 6, 6 plus 3 is 9 by 2, and this is the foot of perpendicular from the point minus 2 comma 3 to the line x plus y minus 4 is equals to 0. So you need to memorize this relation to find that foot of perpendicular, right? Just have a look at this, and in then 36 I will discuss about the image of the point. Just have a look. Image of a point with respect to a line. See, a point px1 y1 is given and a line L ax plus by plus c is equals 0 is given. We are going to find the image of this point P with respect to that line. So for suppose if you imagine a mirror in the place of this line, okay, then its image will be formed in the other direction, okay. And for sure, see, as per the properties of the image, the original point P as well as the image point Q both are at equidistant from the line, as well as the line joining this P and Q is perpendicular to the given line. Here this Q is there, right? This Q is the image of P. Right. And actually we don't know the coordinates of that Q, and that's what we are going to find. So for that you just let the coordinates of Q as h comma k. Is it right? Once again look there. I have a point P x1 y1 and a line ax plus by plus c is equals to 0. We have to find image of that point with respect to the line. So the image of the point with respect to the line, see, is another point which is equidistant from the line just like at P, and the line joining PQ is also perpendicular to the line, and now our target is to find this h comma k in terms of x1 y1 as well as the coefficients a b c. So for that again we need to move just like in the case of foot of perpendicular. But here if you look there, this is point P and this is point Q. See, as per the property of the image, this P and Q are equidistant from the line. So if you say this point, take it as some m, which is the midpoint of this PQ, and it lies on ax plus by plus c is equals to 0. Yeah, since m is the midpoint of PQ, what will be the coordinates of that m? Yeah, P is x1 y1, Q is h comma k. Then the coordinates of that m are nothing but h plus x1 by 2 comma k plus y1 by 2. You just use midpoint formula for x1 y1 and h comma k, and that m is what? H plus x1 by 2 comma k plus y1 by 2. Is it right? The midpoint formula just I used, okay. And now to find that h comma k, use above procedure same, okay. But first what you have to identify, since PQ is perpendicular to the line here, just like in the above case. PQ is perpendicular to the line L, then again what we have in our hands? See, that implies again what? Slope of PQ into slope of L is equals to -1. And again, what you say about slope of PQ? Slope of PQ is what? This P is x1, y1, Q is h comma k, and its slope is given by k minus y1 by h minus x1 into slope of L is what? Minus a by b, and that product is equals to -1. Here further we need to simplify. See, the minus term will get cancelled. As we discussed in the above case, if we rearrange, you will get that h minus x1 by a is equals to k minus y1 by b. Yeah, that's what we have in our hands. Okay, just the thing as we discussed in the previous case. So I have that h minus x1 by a is equals to k minus y1 by b. Just look there. For the space concern, I am erasing this. Yeah, at the end what I have? Since that PQ is perpendicular to the line L, as we discussed in the above case, we have that h minus x1 by a is equals to k minus y1 by b, and since these two are equal, again take it as some t. Yeah, that's what right now. And now again, if you write h comma k, h is equals to at plus x1 as well as k is equals to bt plus y1. There ends the task. And the next thing, if you observe the above proof for foot of perpendicular, there the point h comma k is on the line, but here the point M is on the line. So that's what we need to use. Okay, since M is on the line L, M is on the line L, so A into, in the place of x, replace its x coordinate, h plus x1 by 2 plus B into k plus y1 by 2 plus C is equals to 0. Now here we need to make again what? T as the subject, and we have h is equals to at plus x1 here. Okay, and k is equals to bt plus y1 here. Use these two in the place of h and k now. Yeah, and further that implies a times of h is what? At plus x1 is there, plus b into k is what? bt plus y1, one more y1 is there, plus 2c is equals to 0 by multiplying everything with 2 again. Okay, this is a further simplification. So yeah, x1 plus x1 is 2x1, y1 plus y1 is 2y1, and then send everything that side and make a t as subject as we discussed in the above case, and the t will be a 2x1 minus 2 of ax1, b 2y1, so 2 is outside, and then by1. Okay, and 2c, if you send that side, minus 2c divided by a square plus b square. Just as we discussed in the case of foot of perpendicular, there you get the t value as minus ax1 plus by1 plus c by a square plus b square. You don't have the 2 there, you just have just minus. But in the case of image, here you have minus 2, not just like 1. Okay, look there. In the previous case, we found this particular point M as the foot of perpendicular using x1, y1 and the line. Here in this case, we found the image, okay, using the same procedure. Just have a look. For doubts, with the complete procedure, at the end we arrive to this relation that h minus x1 by a is equals to k minus y1 by b is equals to minus 2 of ax1 plus by1 plus c by a square plus b square. See, in the question, line is given. So a, b, c we will have. A point x1, y1 is given. So x1, y1, a, b, c all are given things. Just h comma k we need to find. For that, use this relation. There ends the problem. Okay. So memorizing this relation is one part. If minus 2 is there, it indicates a rule to find image. If just minus 1 is there, it indicates a relation to find the foot of perpendicular. See, these two I can combine in another way. For suppose, image or foot of perpendicular. See, if I have a point like at plus x1 comma bt plus y1. Just take this point, okay? The question itself x1, y1 is given. From the line itself we can find AB. So AB I have, x1 I have, and if I write this at plus x1 comma bt plus y1, this represents foot of perpendicular of the point x1 y1 to the line, or this represents image of the point x1 y1 with respect to the line. It represents foot of perpendicular if t is equals to minus of ax1 plus by1 plus c divided by a square plus b square, and it represents image if t is equals to minus 2 of ax1 plus by1 plus c by a square plus b square. So to calculate image of the point or foot of perpendicular of the point, either you need to memorize this relation, or otherwise you just memorize this point with this t value. Find t value first and use this t value in this point, that will give us the image, or use this t value, that will give us the foot of perpendicular. So to find foot of perpendicular or image, either you just memorize this point along with these t values or this direct relation, no problem. Okay, just have a look and we are going to solve few problems related to the image right now. Okay, just look at the problem on the board that 2, 3 is the image of 5, 8 with respect to a line, and now our intention is to find that line L. See, actually in 36a we found the foot of image of the point, but here image is given. Okay, see, actually in the picture 3 different terms are involved. Okay, one line along with a point P and its image Q. These 3 are involved in the picture in analyzing the concept of image of a point with respect to a line. See, just we derived a formula to find this image Q if point P x1 y1 and the line ax plus by plus c is equal to 0 are given. Okay, if P and L are given, find Q, use that formula. But here in the question, what they are given? They gave that 2, 3 is the point and its image is what? 5, 8. No problem, anything. 2, 3 is the image of 5, 8. Write 5, 8 there, or 2, 3 here, no problem. Okay, see, 2, 3 and 5, 8 are one another images to each other, right? And this L is there and we don't know that L. That L we need to find. Yeah, see, very simple problem actually. We need to find the equation of L. As we discussed, this P, Q are images to one another with respect to the line. So this P, Q are equidistant from the L. So as we discussed in the previous case, if you say this point as M, easily you can find M which lies on the L, and slope of L you can find using slope of PQ. Slope of L and M point will give us what? Equation of L. Yeah. Now M is equals to midpoint of PQ, and that midpoint of PQ is what? These two are points PQ. So as I told you, x1 plus x2 by 2, so which is 7 by 2 comma y1 plus y2 by 2, nothing but 11 by 2. Yeah, midpoint of PQ is clear. And then slope of L. Slope of L is equals to minus 1 by slope of PQ. Why? Because PQ and the line L are perpendicular to one another. So that is equals to minus 1 divided by slope of PQ. See, 5, 8 and 2, 3, y2 minus y1, 8 minus 3 divided by 5 minus 2. If you simplify, you will get it as minus 3 by 5. So what I have in our hands? Slope of the line is there. M, a point on the line is there. So a point M and line L are there on the line. Then easily we can find the equation using slope point form. So at the end, equation of L is what? Equation of L is y minus 11 by 2 is equals to minus 3 by 5 times of x minus 7 by 2. Further we need to simplify. Okay, just look there. See, 3 terms, point P, its image Q with respect to line, are the 3 items involved in the picture actually. And out of these 3, if you know any 2, either P and L, you can find Q. Either Q and L, you will find P. If you have P and Q, you will find L also. Okay, this is one such problem. Just have a look.